Okay, this video is intended to get you started on the project problem. Here's a diagram of the situation. This out in here is all desert, and we've got this roadway that starts here at 0 and ends 50 miles directly east of the starting point. So this red line is a straight road on which the truck can travel 75 miles per hour. And we're starting here 40 miles directly north of this starting point. And we want to figure out the best route for getting from here to here. One way to do that would be to drive the truck 45 miles per hour all the way down to here for 40 miles, and then drive 75 miles per hour for 50 miles directly east. That's probably not going to be the quickest time. And what we have to do is use the fact that distance equals rate times time, so time equals distance divided by rate. And we need a function that will give us the total time depending on the route that this truck driver takes to get from here to here. I'll call this point A and point B to get from A to B. One way to do that would be to drive to some point along the red route directly with this truck. We could call this distance X and this distance 50 minus X. What we need is an expression for the length of this hypotenuse. He's going to drive this distance at 45 miles per hour. Now we know that this distance is 40. This is a right triangle. And he's going to drive the remaining distance. Once he gets to the road, he's going to drive at 75 miles per hour. So the total time, the function for total time that it's going to take him to get from point A to point B is going to be the time that it takes him to drive along the hypotenuse plus the time it takes him to drive along the road directly at 75 miles per hour. So you need an expression for this distance right here, this hypotenuse. We already have an expression for this distance. Time equals distance divided by rate. Add them together and you've got the function for the total time it takes. Now that isn't going to answer the question, what value for X will give him the minimum amount of time. That will require you to take the derivative of your function, set it equal to 0, and find the critical numbers, and then prove that that value for X creates a minimum time. So I'm going to leave you with that information and see what you can come up with before we get into the second half of the problem. Okay, there you go. I'll end the video.